everyone, thank you so much for clicking onto the video. Today we're going to be looking at functional groups. So we're going to interpret and use the terms homologous series, functional group, alkyl group, aliphatic, alicyclic, aromatic and saturated, and we're also going to use the general formula of a homologous series to predict the formula of any member of the series. So we're going to quickly run through some definitions. The first is a homologous series. So a homologous series is a series of organic compounds that have the same functional group, but with each successive member differing by CH2. So for example, we'll be learning about alkanes. So alkanes have the general formula CnH2n plus 2. So the first alkane we have is methane, and it's CH4. And then the second alkane that we have is ethane, which is C2H6. So it differs by CH2. A functional group is a group of atoms responsible for the characteristic reactions of a compound. So an example of a functional group could be an alkane, or an alkene, or an alcohol. And there's many, many more. An alkyl group is an alkane group that has one less hydrogen. So when we come to look at different molecules, for example, for alkanes, when we have a branched chain, we have an alkyl group attached. The definition of aliphatic is a compound containing carbon and hydrogen joined together in straight chains, branched chains, or non-aromatic rings. The meaning of aromatic is just the name for a compound that contains a benzene ring, and we'll be looking at that quite a lot later in the benzene subtopic. And then the definition for saturated is a species that only has carbon-carbon single bonds, for example, an alkane. And an unsaturated species is a species that has carbon-carbon double bonds or triple bonds, just anything except for only carbon-carbon single bonds. So alkenes have carbon-carbon double bonds, so they'd be classed as unsaturated. We also need to know the definition of alicyclic, and the definition is that it's a compound that contains one or more all-carbon rings, which may be either saturated or unsaturated, so either carbon-carbon single bonds or carbon-carbon double bonds or triple bonds, but do not have aromatic character, so they don't have any benzene. Now we're going to talk about predicting formulae. So we can predict the formula of any member of a homologous series if we have the general formula. For example, predict the formula of hexanol given that the general formula of an alcohol is CnH2n plus 1 OH. Now the only thing we actually need to do here is to remember our prefix. So because the prefix is hex, this tells us that there's 6 carbons. And so what that means is that we sub in to the general formula N equals 6. And so the formula of hexanol is C6H2 multiplied by 6 plus 1 OH. And so this gives us that hexanol has the formula C6H13OH.